Chapter 10.1, Tree Diagrams and the Counting Principle. So today we're going to start our chapter on probability. Okay, so vocab for today is outcome. It is the result of some sort of action. I flip a coin, I get heads. That is an outcome. A sample space is a list of all possible outcomes. A tree diagram is an organized list. It's a different way to find your sample space. And the counting principle is a way to find out the number of possible combinations. Okay? For example, if your choices are a ham sandwich and chips, or a ham sandwich and an apple, or a turkey sandwich and chips, or a turkey sandwich and an apple, how many combinations are there? In that small example, there are 4 different combinations of sandwich and side that you could get. So let's take a look at example 1, finding a sample space. So we're going to use this menu to construct a sample space to list all of the possible outcomes and then identify how many outcomes there are. Now, you need to make sure that you are very methodical about this. Okay, what do I mean by that? Meaning, come up with a way, whether it's my way or your own, to make sure that you are working through all of the possibilities in a very uniform way so that you don't miss any. Don't just kind of jump around. So for example, I'm going to start here with my main dish of grilled chicken. So I'm going to use G for grilled, or B for baked to stand for the chicken, and then S, V, and R to stand for the salad, vegetables, and rice. It is definitely okay to abbreviate, especially when you're going to be writing a bunch. So if I have grilled chicken, I can have either a salad, or I can have grilled chicken with a vegetable, or I can have grilled chicken with rice. So if I get grilled chicken, these are my 3 options for sides. So each of these is one event. Okay? Or I can get baked chicken instead of grilled chicken. So another event would be getting baked chicken with a salad, or baked chicken with vegetables, or baked chicken with rice. Each of these is also an event. So this is my sample space. Now, this one isn't huge. Okay, it's not unreasonable to make. However, sometimes you're going to have sample spaces that get very large, and even though it can be very meticulous and boring, if you are asked to make the sample space, you need to do so. But the question is also, how many possible outcomes are there? There are 6 possible outcomes. So if 6 people went to dinner, it is conceivable that each person had a different combination of foods. Okay, so that is a sample space. So in example 2, we're going to use what we call a tree diagram. So I'm going to roll a standard number cube, and then I'm going to toss a coin. List all of the possible outcomes. So I'm having 2 things happen. First, I'm going to roll a cube, and then I'm going to toss a coin. So my possible outcomes for my cube are a 1, a 2, a 3, a 4, a 5, or a 6. If I roll that dice or toss that number cube, that's all I'm going to get. Oh, if I can spell. Okay. However, let's say I roll a 1. And then I toss the coin. My 2 options for that coin toss are to get heads, or I can get tails. If I roll a 2 and toss the coin, I can still get heads or I can get tails. If I toss a 3, I can still get heads or still get tails. And so it goes. I'm going to make these a little smaller just so I don't run out of room. Tree diagrams don't need to be big necessarily. You just want to be sure that you have enough vertical space this way that you can fit in all of the outcomes of the second event. So this is the first event. Event number 1, I roll a cube. Event number 2, so what I do next is then I flip a coin. So then I follow the lines for my outcome. So if I roll a 1, I can get a heads. So 1, heads. Or I can roll a 1 and get a tails. 1, T. So here are my first 2 outcomes. Or I can get a 2 and a heads, or 2 and a tails. 3 heads, 3 tails, 4 heads or 4 tails, 5 heads, 5 tails. Excuse those 7th graders, they're kind of loud.
No, we're not.
Okay, 6 heads or 6 tails. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 possible outcomes when I roll a cube and then toss a die or toss a coin. So this is called a tree diagram. Granted, mine's not very neat. I know yours will be much neater, but that's what a tree diagram typically looks like. Okay, so let's take a look at example 3, the counting principle. The counting principle says, I'm going to move this over a little bit so I have some more room. There are m ways of making one choice and n ways of making a second choice. So there are m times n ways to make the first choice followed by the second one. So let's take a look at my ice cream menu. You choose one item from each category, one flavor, one topping, one cone. How many different desserts can you order? So rather than creating a sample space or using a tree diagram, I can use the counting principle. So I have 1, 2, 3, 4, 5 choices of flavor. I have 1, 2, 3 choices of toppings. So if I multiply 5 times 3, I get 15 different combinations of flavors and their toppings. But then I also see that I have 2 cones down here. So then I'm going to multiply 15 times 2. There are a total of 30 different combinations of flavors, toppings, and cones that you can make with these choices. Now, 30 would have been a very big sample space. So instead, I can use the counting principle. Choice 1 times the number of options in choice 2 times the number of options in choice 3. So flavors, the number of flavors, times the number of toppings, times the number of cone choices, equals the total number of combinations. Okay? That's it for 10.1. If you have any questions, come see me in the morning. If not, get your quick checks and see why you completed.